This is the largest mass-produced crane building block set to date. The Leaper LTM 11200 from Mold King. Compared to LEGO's recently released 42146, it not only completely surpasses it in scale and size, but also, with 3 main controllers, a total of 14 channels, and 20 motors, it basically achieves a full functional recreation of the original vehicle. The total arm height is 160 centimeters, and the finished model is 121 centimeters long, with the vehicle itself measuring 108 centimeters. Based on the prototype vehicle's length of 19.95 meters, the scale is about 1 minute and 18.5 seconds, while the LEGO 42146 is at a 150 scale, so in terms of scale, the LEGO version is only about 37% the size of the Mold King model. In our rating review, we will thoroughly analyze its design principles and also test the final product's performance. Let's start by unboxing this giant item. The shipping box is enormous, weighing 14.5 kilograms, and the colorful inner box itself weighs 13.7 kilograms. The box continues Mold King's signature black background design. In addition to the finished product render, the top left corner also displays the set number, recommended age, and the number of pieces. The top right corner indicates that this is a flagship level set. On the back of the box, besides an image of the crane arm not fully raised, it also shows the finished product's dimensions and some of its interactive features. It's worth noting that the side of the box specifically introduces Mold King's brand new Hall motor and the app. The other side displays the power components, pneumatic accessories included in the set, as well as special parts like the carbon fiber cross-axle and counterweights. When you open the box, there are 2 inner parts boxes. The parts inside are packed very tightly, with almost no empty space. A total of 8,506 pieces are divided into 59 parts bags and 14 major building steps. You think that's all? No! There are also 12 pneumatic parts bags and 5 electronic control component bags. Without a doubt, this is the set with the most power components we've ever built, no exceptions. There are 3 main controllers alone, 1 6-channel and 2 4-channel, and all of them are Hall effect controllers. There are 3 XL motors, 5 L motors, 4 Hall effect L motors, 4 M motors, 3 Hall effect M motors, 1 servo motor, and several extension cables. 3 main controllers and 20 motors. I'm not even sure if this counts as the best configuration ever for a mass-produced Technic building set worldwide so far. Next, take a look at these 2 building manuals sealed with heat shrink film. Together, they're over 2 centimeters thick. The first manual even includes a 4-page color introduction at the beginning, giving some background on the reference model for this set and the design of the building blocks. The sticker application steps are placed at the end of the manual, and just the sticker instructions alone take up 3 pages. There are a total of 7 sticker sheets like this, and as for the building process, there are 1,580 steps in total, with an average of 5.4 pieces per step. This level of detail is considered quite thorough among domestic building block brands. Before we start building, we can follow the manual to label the motors, so we don't accidentally connect the wrong plugs later on. Also, it's best to test all the motors and pneumatic components beforehand. Next, we'll start assembling the chassis. First up is the structure related to the raising and lowering of the support legs. The designer has incorporated a pneumatic system here. 1 L motor powers 2 blue air pumps, and a servo motor is responsible for switching the air channels. These 2 motors are plugged into the same channel. When we switch the remote control direction, the pumping power provided by the L motor will continue, while the SIV motor will achieve the telescopic effect of the pneumatic push rod by controlling the pneumatic switch. As for the vehicle's driving and steering, the driving power for each axle comes in through a cross-axle like this. Then the 12-tooth gear drives the 28-tooth differential, and the power is transmitted to both the left and right sides. Before reaching the suspension drive axle, the power also passes through a set of 20 to 12 gear pairs, and the suspension drive axle itself has a 5.4 to 1 reduction ratio, so the total gear ratio is 21 to 1. Steering is achieved through 12 gears driving the rack component. The power source is this 10-20-tooth gear. In addition, the designer also added a steering limit design here. The power for the 10-20-tooth gear I just mentioned comes from this L motor labeled A1. Along the way, it passes through a set of 20 to 12 gears, a set of 8 to 24 gears, and another set of 20 to 12 gears, then reaches a worm gear, and is ultimately driven by this worm gear. It's worth noting that the addition of this 24-tooth clutch gear provides protection for the related linkage structure when the vehicle reaches the steering limit. When assembling this module, we need to make sure that the angles of the front and rear suspension drive axles are kept consistent. Otherwise, any difference in their angles will be fixed in place. Additionally, you can also run some tests during the process. The chassis we're holding right now is only half of the entire vehicle's chassis. As you can see, each axle here has both steering power and driving power. The steering power for each comes from the beige 20-tooth gear driven by the worm gear we mentioned earlier, and they all share the same L motor. You can see that the drive path is very long, which is why the set includes some carbon fiber cross axles to eliminate the negative effects caused by this. The driving power comes from the cross-axle connector at the top, which transmits power downward through three 16-tooth gears to the height of the axle, and then connects to the cross-axle we mentioned earlier. At this point, we can also insert the motor to run a driving linkage test. Similarly, the steering part can also be tested by adding a motor. The vehicle uses two XL motors for driving, each combining power through a 4-tooth gear. Both motors drive the V8 engine, then the power is transmitted downward through three 16-tooth gears, and finally connects to the cross-axle connector mentioned earlier. After testing, the linkage is still quite smooth. The steering test also went smoothly without any issues. After the entire chassis is completed, we can do a power on test. This includes the driving linkage and the steering linkage. All the tests turned out to be smooth. There were no problems with the engine linkage either. Let's put on the wheels and take another look. You must do as much testing as possible during the entire assembly process, because for a set of this level, it is very difficult to make adjustments at the finished stage. In addition, it also requires a certain amount of patience to organize the motor wires during the assembly process. Let's look at the structure for opening and closing the support legs. Power from the universal joint goes through gear sets to the large push rods on each side. One end of the support leg is the rotation center, and when the large push rod extends, the opening action is done. The power for the universal joint comes from a Hall L motor hidden right here in the middle of the chassis. In addition to opening, the support legs can also extend and retract. Their power comes from an M motor hidden inside each leg, which, through a set of 24 to 8 gears, drives the rack part to extend and retract via this worm gear. The 24-tooth clutch gear also serves to protect the mechanism at its limit positions. As for the raising and lowering of the support legs, that's when the pneumatic system we introduced at the very beginning comes into play. Let's take a look at the design of the turntable here. The rotating weaving turntable uses a double layer of 424121 11 by 1/4 circle ring rack parts, but it does not have a staggered design like LEGO's 42146. After the rotational power for the turntable enters via this cross-axle, it drives a 24-tooth gear via one gear, then reaches this 8-tooth gear on the back, serving as the planet gear, driving the entire turntable module. The designer also added a 24-tooth gear next to this gear to increase the bonding stability between it and the rotary weaving turntable. The other three 8-tooth gears also serve to increase stability. Power for the two winch mechanisms comes from these two white Hall M motors. The main winch transmission uses 3 sets of 20 to 12 gears for a total ratio of 4.63 to 1. The auxiliary winch transmission has 2 sets of 20 to 12 gears with a total ratio of 2.78 to 1. After finishing the turntable module, use the wire organizer to arrange these wires. You can see the overall structural strength of this turntable is good. After the turntable is installed onto the chassis, testing is still an essential step. Unlike most small and medium crane building blocks, this crane's luffing cylinder doesn't use a ready-made push rod, but is built from individual parts. After power comes from the Hall L motor, it goes through 24 to 8 gears, then 8 to 8 gears, and reaches the 2 worm gears at the front. Each worm gear drives a 24-tooth gear, which drives a coaxial 12-tooth gear, powering the rack's extensions and retraction. Here, let's take a look at the boom, especially the telescoping mechanism of the second and third sections. The telescoping power for the second section comes from this Hall L motor located near the lower rear part of the boom. After passing through a set of 24 to 8 gears, the power is transmitted forward, then drives a total of 3 worm gears up front. Each worm gear drives an 8-tooth gear, and ultimately, these 3 8-tooth gears drive the rack at the base of the second section to achieve the telescoping effect. The extension and retraction of the third section is achieved using 2 ropes. One is responsible for pulling out the third section when the second section extends, and the other pulls the third section back when the second section retracts. Although this set is quite large in scale, its mechanism is the same as the Growth and the Yellow Crane models from Yuxing Moang that we've built before. Next are 2 sets of linkages for the superlift on both sides. One set unfolds the entire superlift module, done with a large push rod on each side. Power comes from this dark gray L motor in the middle. Opening and retracting the superlift left and right is controlled by a Hall M motor, which operates a small push rod on each side.